Hello guys, today we've got a task to sketch x plus 2 squared multiplied by tan x. So immediately we recognize that this is a product of two functions. We've got x plus 2 squared as one function as tan x, and tan x is the other. So let's go ahead and sketch them separately, see where we can go from there. So we've got x plus 2 squared, so we've got a root at minus 2, or a repeated root. And we've got a y-intercept of 4. Let's drag that down. Got minus 2, 0, 4, 0, 4. And also we've got tan x to sketch. So we've sketched that below. There we go, we've got tan x. Now let's take this sketch part by part. So now let's look at the part where x is larger than 0. So for x plus 2 squared, our graph is always getting bigger. So we can say that it's tending towards infinity. And for tan x, well, our graph is repeating. So we increase from 0 to pi over 2. Then we go down to negative infinity to pi, to 0 at pi, and then back off to infinity. So we're expecting some sort of repeating pattern. So if we sketch in red, so we've got, let's sketch from 0 to pi over 2. Well, we can see this as a multiplication. So we're timesing this region of the graph by a number larger than 1, meaning it will be, the values of y will be getting larger. So we can say that this graph tends to infinity at a faster rate, like such. Yeah, that makes sense. And what about between pi over 2 and pi? Well, for tan x, this region of the graph is tending towards negative infinity, and again it's happening at an increasing rate. So we can say that it's behaving like this because this point has now been enlarged by a scale factor to go to the point below. And then if we look at pi to 3 pi over 2, well, yes, this will be increasing again, increasing tan x, and it will go to positive infinity. But what's different from when we were sketching 0 to pi over 2? Well, now we're multiplying by a part of x plus 1, x plus 2 squared, which is even greater. So we can say that it's going to infinity at an even greater rate. So we should notice that the gap here should be less than the gap here. And this pattern applies here. So we've got a larger gap now, yet we're still tending towards infinity. Likewise here, something like this, where our gap just keeps on increasing. Same with our negatives. Now that's fine. Now let's consider when x is less than 0. So there's a few parts to really consider with our graph. Let's consider between minus 1 and 0, because that seems to be very important. And then from minus 1 to our turning point, and then minus 2 and any values less. So I think it'd be a good idea to see where x plus 2 squared is greater than and less than 1. So if you draw on y equals 1 and work out this part here and this part here. So we're looking for when x plus 2 squared is equal to 1. So you've got x equals minus 3 and x equals minus 1. And then we've got minus 2 there. So essentially, we need to consider this region here, this small. We also have to consider this region between minus 2 and 3. And then the last region is when x is less than minus 3, so greater than 1. Right, let's start off with this blue shaded region. So we have to sketch from minus 1 to 0, which will be from around about here to here. Now, the value of y between minus 1 and 0 on this graph here is greater than 1, we know that. So we can say that tan x is being stretched. So we can draw that up until here. And then as it approaches 1, you can almost see it as the graph just goes back to tan x, because tan x times 1 is again just tan x. So let's make that curve a bit smoother. Here, we've got 0.1. We're actually meant to be working in pi, but you get the gist. Now let's look at the next region between minus 1 and 2. So on our tan x, or our new graph, we're looking between here and 2, so which is roughly about here. So we know that at minus 2, the graph is in fact 0. Now, as we go from minus 2 to the positive, we're multiplying by a scale factor less than 1. So our tan x graph is getting smaller. However, it still tends to infinity. Because when multiplying by a fraction less than 1, when we're multiplying a graph that tends to infinity by a fraction less than 1, this multiplication of a fraction is quite insignificant, as tan x still approaches the asymptote and goes towards infinity, so that's fine. Now we need to look between minus pi over 2, which is roughly minus 1.57, and minus 1. So, here, between minus 1 and minus 1.57, as we go from minus 1 to minus 1.57, our value of y in our sketch here goes closer and closer to 0. So essentially our tan x graph is getting smaller. So instead of continuing this direction, we move closer to the asymptote like such. Should be a more of a smooth curve. And yeah, this just drags on to infinity. Now we're considering the yellow region between minus 2 and 3. Well, we know for certain that the graph will be at pi 0, minus pi 0. Now let's assess between minus pi 0 and our last part where our graph hits 0. So between minus pi, let's just map what this is like on the graph above. So we're considering minus pi, which is minus 3.14. Actually, no, we shouldn't do it like this. We're looking at the yellow region, so we need to look between minus 2 and 3. So we know minus 2 is here, right here, and minus 3 is about here. So what happens at minus 3? Well, at minus 3, x plus 2 squared equals 1. So we can say we've got a point here. And then between, we're just multiplying by a fraction less than 1. So we've got tan x will, well, our new sketch will look something like this. Now, our final region to consider is the purple region where x plus 2 squared is greater than 1. Yep. So if we go here, this point here, what was this? This was minus 3. This was 1. And then in between minus pi and minus 3, we're multiplying by a number greater than 1. So we can say our new graph is larger than tan x, and then before minus pi, we're still timesing by a larger greater than 1. So our graph will be greater than, well, our graph will be sort of scaled up by a scale factor, and it goes to negative infinity as tan x does, instead at a faster rate. And essentially this is what our sketch looks like. So yeah, this is quite an interesting graph. I like how we broke it down into different parts. And yeah, that's all for today. Hope to see you in the next. Goodbye.